Welcome. Today we will be discussing about a very important topic in the chapter of real numbers or in the chapter of rational and irrational numbers, which we call rationalization. A very but a simple topic with different types of sums. We will learn the concepts of rationalization and see as to how rationalization can be a big scoring opportunity for all the students. Thank you. So basically rationalization is the process of removing an irrational number from either the denominator or the numerator. Now before we move on to the process of rationalization, we will need to know about certain terms. One is the radical. Radical is the root that we are looking to find out. It can be a square root, it can be a cube root, or it can be any root. It can be an nth root as well. So the radical is basically the root that we are looking to find out. Now we come to another term. Radicand. Radicand is the term for which we are finding out the root. So if we are writing root over of a plus b, then a plus b becomes our radicand. So radicand basically is the term for which we are finding out the root or cube root or nth root, whatever it is. Now, since we have a better understanding of these terms, let us move into the sums and solve them one by one and type by type. Monomial surds. But before we move on to the concept of monomial surds, let us know what is basically a surd. When we write of A is a surd, if A is a positive number, N is a positive number, and nth root of A is an irrational number. Now, what do we mean by a monomial surd? A surd consisting of only one term is a monomial surd. Now, let us see how do we rationalize monomial surds. Express each of the following as a rational denominator. 2 by root 7. Second sum is 4 into cube root of 5 by 3 into cube root of 16, and the third sum is root 10 minus root 5 by root 2. So when we are solving the first sum, which is 2 by root 7, if we look at the first sum, there is only one monomial surd in the denominator. So what we do here is we multiply both the numerator and the denominator by the same term that we have in the denominator. That means we are multiplying this term with root 7 in the numerator and root 7 in the denominator. This is 2 root 7 by root 7 whole square, which gives us 2 root 7 by 7. For part B, we have another monomial surd in the denominator, which is 4 into cube root of 5 by 3 into cube root of 16. Now for this sum, what we do here is, let us first simplify the denominator. Cube root of 16 can be written as cube root of 8 into cube root of 2. Why? Because we know root over of A into root over of B equals to root over of AB. So cube root of 8 into cube root of 2 would give you cube root of 16. Now cube root of 8 can be written as 2 to the power 1 by 3 whole cube into cube root of 2. Or you can also write it as 2 to the power 3 into 1 by 3 into cube root of 2, which is 2 into cube root of 2, which means cube root of 16 is simplifying to 2 into cube root of 2. So from here we can write 4 into cube root of 5 divided by 3 into 2 into cube root of 2. So this is the simplified form of this sum. So our simplified form becomes 4 into cube root of 5 by 6 into cube root of 2. Now since we need to rationalize the denominator, my rationalizing factor RF in order to remove the cube root would be 2 to the power 2 by 3, which is cube root of 2 square. Why is this my rationalizing factor? Because cube root of 2 means 2 to the power 1 by 3. In order to make it into a number which is rational, we will have to convert it into 2. That means we will have to multiply it with 2 to the power 2 by 3. Now when we are multiplying it with 2 to the power 2 by 3, then we will get 2 to the power 2 by 3 plus 1 by 3, because when we are multiplying terms with the same base, the power gets added. So 2 to the power 3 by 3, which is 2 to the power 1, equals to 2. So my rationalizing factor in this case would be cube root of 2 square. That means we will be multiplying 4 into cube root of 5 with cube root of 4. Similarly, in the denominator, we will multiply 6 into cube root of 2 with cube root of 4, which will give us 4 into cube root of 20. 5 into 4 will give us 20, divided by 6 into cube root of 8. Now we know that cube root of 8 is 2, so we will be left with 4 into cube root of 20 by 6 into 2, which is 4 into cube root of 20 by 12, which is 1 by 3 into cube root of 20. Now moving on to the third subpart. Root over 10 minus root over of 5 by root over of 2. Here also, if you look at the denominator, it's a monomial surd. So, my first step would be root over of 10 minus root over of 5 by root over 2 into root over of 2 by root over of 2. That means we are multiplying the numerator and denominator again by root over of 2. What do we get from here? We get root 10 into root 2 minus root 5 into root 2 by root 2 whole square, which is root 20 minus root 10 by 2. Now, a lot of the students keep the answer to this point, but this is not correct. When we get root over of 20, root over of 20 can be written as root over of 2 into 2 into 5 by the method of factorization. Now since we have two 2's inside the root, this can be simplified and written as 2 root 5. So this has to be further simplified to 2 root 5 minus root 10 by 2. So my simplified answer would be 2 root 5 minus root 10 by 2. The other common mistake that students make and which should be avoided is cancelling this 2 and this 2. That can never be done. While cancelling, you must consider that there is a plus or a minus sign in between. If that is the case, you cannot just cancel a term with another term in the denominator. You have to take terms in common and then cancel. To type 2, which is rationalizing of binomial surds. Now when we talk about binomial surds, we can have 2 or 3 types. One is you have a surd along with a number. So this is also considered as a binomial surd and an irrational number, because the sum of a rational and an irrational number gives you an irrational number. You can also have 2 surds added or subtracted together and you can have a sum like this. So let us start off with the first part. which is 15 by root 31 minus 4. In these kind of questions, we have to multiply the numerator and denominator by conjugate surds. I repeat, in these questions, we have to multiply and divide the numerator and denominator by the conjugate surds. A sum like this. So let us start off with the first part, which is 15 by root 31 minus 4. In these kind of questions, we have to multiply the numerator and denominator by conjugate surds. I repeat, in these type of sums, we have to multiply the numerator and the denominator by conjugate surds. What do we mean by conjugate surds? So let us understand the concept of conjugate surds. So if we have a number which is root a plus root b, and this is a binomial surd. So if we look at this term, we have two surds, root a, root b, and a plus sign in between. So the conjugate surd of this surd would be root a minus root b. That means when we change the sign in between two surds or two terms associated with surds, then we get conjugate surds. So in this case, 15 by root 31 minus 4 has to be multiplied by its conjugate surd, which is root 31 plus 4 by root 31 plus 4. Now why we do this? We do this because when we multiply, let us first multiply the numerator. So we get 15 into root 31 plus 4. In the denominator, we will get root 31 square minus 4 square. The advantage of multiplying a binomial surd by its conjugate surd is it follows the formula of a square minus b square then, which means the root of the term is negated. So you will have 15 into root 31 plus 4 by root 31 whole square is 31 minus 4 whole square is 16. So you will have 15 into root 31 plus 4 by 15, which will give you the answer of root 31 plus 4. Now since 15 and 15 you have in the numerator and denominator, you can cancel them off. In the second part also, we find that we have a binomial surd, root 7 plus root 3. So in this case also, we will multiply by its conjugate surd. Since we had a binomial surd, so we are multiplying by its conjugate surd. That means we are multiplying by root 7 minus root 3, the numerator and the denominator both. So we will have in the numerator root 7 minus root 3. In the denominator we will get root 7 whole square minus root 3 whole square, which will give us root 7 minus root 3 by root 7 whole square is 7 minus root 3 whole square is 3. That means root 7 minus root 3 by 4, which will be the answer. Now moving on to the third sum, which is root 5 minus 2 root 6 by 2 root 6 minus 3 root 5. Like in the previous two sums, again we multiply this with its conjugate surd, which is 2 root 6 plus 3 root 5 by 2 root 6 plus 3 root 5. So in the next step, we will have root 5 minus 2 root 6 in brackets with 2 root 6 plus 3 root 5 again in brackets divided by 2 root 6 whole square minus 3 root 5 whole square. Now when we are multiplying, so let us multiply root 5 first. So root 5 into 2 root 6 will give us 2 root 30. Root 5 into 3 root 5 will give us plus 3 into 5. Root 5 into root 5 will be 5. Minus 2 root 6 into 2 root 6 would be 4 into 6. Minus 2 into 3 would be 6. And root 6 into root 5 would be root 30. By 2 root 6, 2 square would be 4 into root 6 whole square would be 6. So 4 into 6 minus 3 square will be 9. Root 5 square would be 5. So we will have 2 root 30 plus 15 minus 24 minus 6 root 30 by 24 minus 45, which will give us 2 root 30 minus 6 root 30 would be minus 4 root 30, and plus 15 minus 24 will be minus 9 by 24 minus 45 would be minus 21. So if we take the minus common, we will have 4 root 30 plus 9 by minus 21. So you can cancel the minus signs. So you will be having 4 root 30 plus 9 by 21, which will be the required answer. We discussed two types of rationalization. One with monomial surds and the other with binomial surds. In the next video, we will see as to how we can solve for variables using the method of rationalization, that is to find the values of a and b. We will also solve sums for trinomial surds and do more kinds of examples and exercise sums. In order to clarify your doubts, if you have any doubts, you can then always mail it to us and we will solve it for them. You can mail it to us at this email ID, mastiaem@gmail.com. Mail us your doubts and we will solve it for you. Thank you.